Okay, so today again, no slides, but the plan for today is to now actually do something on the real Cardano blockchain, or rather one of the Cardano test nets, because obviously we don't want to use real money. But everything, maybe I should say, so Cardano has a mainnet and two official test nets. One is called pre-prod and one is called preview. And we are going to use pre-prod, which is, I think, as far as all parameters concerned, identical to mainnet. So everything is exactly like on mainnet, except that it's not real money. So all the parameters, I mean, transaction fees, epoch times, everything is the same as on mainnet. So we are going to use that today. And I mean, I don't know how much background in blockchain all of you have, but I thought that I'll do like the first part of the lecture, just talk a bit about Cardano in general, blockchain cryptocurrency, how it works, demonstrate some simple transactions maybe. And then the main part of the lecture will be connecting to what we did last week. So we talked about Marlowe and show how you can actually run or execute a Marlowe contract on a real blockchain. Okay. And before we talk about Cardano or blockchains, I just briefly want to, I mean, could be that I did that in the very first lecture already, I forget, but briefly mention two important cryptographic primitives that are used a lot in all blockchains, not only Cardano, namely hashing and digital signatures. So, I mean, basically the mathematics that's used to make blockchains possible is mostly cryptography. And but luckily one doesn't need to be a cryptographer to use blockchains. But I think nevertheless it's good to at least have some idea of like the basic properties. And as I said, in my opinion, the two most important building blocks for blockchains are hashing and digital signatures. And a while ago I wrote this little demo for those two things. So hashing, there are various hashing algorithms with various like properties and advantages and disadvantages. But the main point is that hashing maps an arbitrary byte string to a fixed length byte string, and in a way that's unpredictable. And so I have this little demo here, so I can enter some text here, gets converted into a byte string. And then I use the SHA-256 algorithm to compute a hash. So at the moment, the hash we see here is of the empty byte string. So some very random looking piece of string of hexadecimal digits. So I can do whatever. I mean, Haskell in Kenya. And if I type that, so we'll always see the, maybe I should make it. We always see the hash. And one thing to note is that, as I said before, so the length of the input can be arbitrary, but the output always has this fixed length. Which fixed length that is depends on the hashing algorithm you use. I think in this case, it's 32 bytes, if I'm not mistaken. The 256, I think, is because it's 256 bits. And right, and as I said, the hashing function works on byte strings of arbitrary length and maps them to a byte string of fixed length. But of course, basically everything serializable can be converted into a byte string. So it's not just byte strings. I mean, as we see here, so I basically encode this text as Unicode or UTF-8. That's then this byte string here, and this is then what the hashing function is applied to. And there are some important properties. So the one important property is that as I said, it's always a fixed length. Another important property is that it's unpredictable. And I mean, that can be made precise using mathematics, but intuitively, so if I just make a small change, for example, if I change this A to a B, you get something completely different. So it's not that small changes in the input result in small changes in the output. On the contrary, it's completely, or should be completely, unpredictable. So that's hashing. And actually, I mean, not in Cardano, but in other cryptocurrencies, most prominently in Bitcoin, hashing is also used for consensus. Maybe you recall in the very first lecture, we talked about consensus, how you manage to synchronize all nodes, that basically all nodes, at least all honest nodes, have like the same view of the world. And the first algorithm that was used by Bitcoin and also by many other cryptocurrencies, proof of work, used hashing. So each time somebody wants to build a block, he is supposed to, I mean, he has like, let's say a prefix, for example, Haskell, and now he has to find a string after this Haskell where the resulting hash has a certain number of zeros in the beginning. And I mean, I can try that by hand. So, I mean, I can just arbitrate. So I try with A, B, C, D, E, F, G, H, I. Hmm. Okay, so I found one that starts with 1, 0. And now that already, I mean, obviously on average, because there are 16 possible digits, on average, every 16th thing I try here would result in one leading zero. But on, for example, for Bitcoin, it's many more than just one leading zero. So now I could go on to try achieving 2 leading zeros. I think I don't want to do that to myself because I would need to try 256 on average until I get 2 leading zeros. And on Bitcoin, this is basically dynamic. So it's calibrated in a way that in order to find something that generates the certain number of zeros takes the whole world. I mean, every Bitcoin miner 10 minutes on average. And there are highly specialized computers that only do that. All they do is try to find byte strings that, when hashed, have a certain number of zeros in the beginning. And it uses an insane amount of energy. So an insane amount of energy in the order of magnitude of a medium-sized country like Belgium is used to do these things, to find inputs that have a certain number of zeros in the beginning. And that is then used, I mean, then you can mathematically prove once you have this, so a task that is where basically there is no clever way to do it. So all you can do is like randomly try stuff over and over again until you are lucky and get your number of zeros. And whoever manages to find something that works first has the right to produce the next block. So that's how so-called proof of work blockchains work, like Bitcoin. So Cardano doesn't use that. Cardano is proof of stake. So where it's different. So you don't need this computational power to solve these so-called crypto puzzles. Instead, it's basically a lottery that works on how much ADA you own. ADA is the native currency of Cardano. Nevertheless, hashing is also important for Cardano. And I think in the very first lecture, I explained that the very term blockchain, I mean, what makes it a chain is the thing that blocks always in their header contain basically a pointer to the previous block. But the way this pointer is actually realized is with a hash. So they contain the hash of the previous block. So hashes are all over the place. That's why I wanted to remind you or explain what hashing is. And it's an important property. I mean, apart from this proof of work thing that Cardano doesn't need, it's an important property that there are no hash collisions. So no matter which text I I do here, I will never, for two different input texts, get the same hash. Now, if you think about that, that's of course impossible because the input space is infinite. I mean, there are infinitely many potential byte strings of arbitrary length, but the output space is 32 bytes or 256 bits is, of course, finite. I mean, a very large number. It's 2 to the power of 256, but nevertheless a finite number. So there must be, according to the pigeonhole principle, there must be two input texts, different input texts that map to this, that have the same hash. But nevertheless, good hashing algorithm would make it practically impossible to find two such input texts. So in practice, you can use a hashing function basically to identify things. So you can just take the hash of two things, and if the hash is different, or if basically the two things are the same, equal if and only if the hash is the same. As I said, mathematically, that's not true. There's a astronomically small probability that you have two different things that have the same hash, but nevertheless, that's so unlikely that basically blockchain relies on this. So things can be identified by their hashes. Right. So that's for hashing. And now for digital signatures. So I have a second demo. So basically, most cryptography, at least on blockchains, it's based on public key cryptography. So, I mean, there are also various different algorithms that can be used, but on a high level, they are all very similar. So somebody can generate a private key. And once you have a private key, you can derive a public key from that. And then the public key is called public key because you can make it public, so everybody can know your public key. But even though it's possible to derive the public key from the private key, it would be practically impossible to, given the public key, derive the private key. And you can do encryption with that, but that is not really relevant on blockchain. But you can also do digital signatures with that, which is very relevant. So, for example, I can have a message. I last hereby send, or whatever. If Karina presents this message at the bank, please give her 108 from my account. Something like this. So I have my private key, the public key, and now each message can be digitally signed with my private key. So now if, for example, Karina now gets this message and takes it to the bank and my signature is attached. Now the bank knows my public key and Karina gives the message to the bank and the signature. And now the bank can verify that indeed the owner of the private key, aka me, created the signature for this message. And now, I mean, there are certain properties that these digital signatures must have. For example, obviously, I mean, naively, I mean, with a like real world signature, if you just do handwriting, you sign something by hand, then of course your signature always looks more or less the same. Obviously, we are all human, so we can't like 100% duplicate our signature, but nevertheless, it always looks very similar. Obviously, this wouldn't work for digital signatures. I mean, you can't have, I mean, this here, I mean, this can't be just my signature independent of the message, because then once I have signed something, it would be trivially, stupidly easy to just take this number and patch it under everything. So one important property of digital signatures is that they depend on the message. So if I now change the message here to, so if Karina wants to cheat and wants 1,000, So she now presents this to the bank, but with my old signature, and it's invalid. And we see that this old signature, which was for the 100, is completely different to the signature for 1000. So that's an important property. Then, of course, there's verification. So you can verify a signature if you just know the message, the signature, and the public key. But it's only possible to create a signature if you also know the private key. And I mean, this is again similar to what I said about hashing. So everything is not 100%. So there's always like astronomically small probabilities that you could break one of these conditions. But in practice, it's safe enough. And it's much safer, I would assume, than like a normal handwritten signature. So this is something that blockchains rely on. I mean, we were talking again in the very first lecture about transactions, these entries in the ledger, and the way individual transactions are secured independent of that. Has nothing to do with consensus or anything like that. It's just that transactions are signed. So I could have a transaction, whatever, send 100 ADA to Karina. And then I would basically put that, obviously it wouldn't be in English, but basically, I mean, intuitively it says something like this. And that would then be, my signature would be attached. And my public key is sort of my address on the blockchain. So this is what identifies me, but I keep my private key private. And if I want to send money to somebody, then I would sign this transaction with my private key. And then everybody else can verify that I actually created this transaction because they can just check my signature. And when I said that people are identified by their public keys, that's like not completely true. So in practice, what we use is the hash of the public key. People normally don't know my public key. They only know the hash of my public key. Nevertheless, are there any questions at this point before we go on? So I think next, are there any questions?
No.
Okay, right. Then I think we should now demonstrate like how that's done in practice on Cardano, maybe just with a wallet. So I don't know. I think, Robertino, you have to leave now for half an hour, right?
Yes.
Okay, so maybe Karina, could you paste a testnet address into the chat for me, please?
Yes, let me check Lars because I was checking my wallet. Robertino, you can share with Lars a little bit. Only I need to check something. Please.
Yes.
Yeah, it's fine. I can just keep talking. I just wanted to use Karina because if Robertino has to leave, I wanted to send some funds to Karina and then yeah, and then wanted to ask her to share a screen to so one can see that she actually got the money. And if Robertino has to leave now, then
We can do
I
it
asked for.
in half an hour if it's okay.
No, it's fine. It's fine. And we also don't have to do that. I mean, I can also send money to myself. I just thought it's more impressive if it's a different person.
Yeah.
I can also first talk. It's fine, Karina. Take your time. I can first talk about accounting actually, and then demonstrate that. That's maybe any way better. So
before that,
yeah.
Lars, we have a question from Samson.
Okay.
Samson, feel free to unmute yourself.
Awesome. I've understood how we create a signature, but I've not understood the part of verifying the signature. At this point, you've signed with your private key, created a signature, and then now when we verify, do we use the public key and the message to recreate the signature and then check it? Or how do we check that the signature matches? That's the part I'm interested in.
Right. I mean, of course, I didn't explain the actual algorithm, but no, you need the message, the public key, and the signature. And I mean, there are basically two algorithms. One the one that the signer uses takes the message as input and the private key, and the output is the signature. So that's how you sign. And then on the verification side, you have a second algorithm that takes the message, the public key, and the signature, and then just says yes or no, whether it's valid or not. So you need all three parts to verify. You can't recreate the signature. I mean, if you could, then it would be useless, because then you could just sign on my behalf. So you need the signature as well as input for the verification. So that's just, I mean, that's just how these algorithms work. I mean, if you're interested, and maybe if you have time in the end, I mean, or you can just check on Wikipedia. So one can, of course, I mean, do that. I mean, it's not magic. I mean, there are concrete algorithms, so you have to just do arithmetic. But I mean, conceptually, so to sign, you need the message and the private key, and to verify, you need the message, the public key, and the signature.
Okay, thank
you. And then
the
welcome. Are there other questions? Okay. Okay, then let's talk about accounting models. So, I mean, if I want to send money to somebody on, for example, Ethereum, accounting works like at a bank. So people have their accounts, and those accounts have a balance. So you have a certain amount of Ether in your balance. And if I now want to send 100 Ether to Karina, then the transaction would, I mean, the accounts would be updated. So my balance would be, I mean, the 100 would be subtracted from my balance, and 100 would be added to Karina's balance, and that's it. So exactly as a bank would work. So you basically have global state, the balance of every account, and the transfer just adjusts those balances. That's, however, not how Bitcoin or Cardano work. So Bitcoin and Cardano use the so-called UTXO model. And for that, just shift this, close this. I mean, what I did in the last 2 or 3 years at IOG, or one of the biggest things I did, was teaching this so-called Plutus Pioneer program, teaching our smart contract language Plutus, which we will do in this course starting next week. And all the lectures are fully available on YouTube. So by now we have done 4 iterations of this course. So this video here is from, so if you just Google Plutus Pioneer program, you will find it. We can also put the link somewhere if it's not already there in the README of this course's GitHub repo. Anyway, and in the first lecture of the Plutus Pioneer program, I explained the UTXO model, and I'm very proud of the graphics I created for that. So I just want to reuse that now. Right, let me just. Right, so the UTXO model is also like much closer to Haskell somehow. So it's a much better fit to a functional programming language. Or, I mean, as I said before, accounting model Ethereum is like global state that gets modified. So each transaction modifies the global state by subtracting and adding amounts to balances. And in the UTXO model, nothing ever changes, basically. So in the UTXO model, if Alice wants to send 10 ADA to Bob, UTXO, I should say, stands for unspent transaction output. So the state of a UTXO blockchain is this set of so-called UTXOs, unspent transaction outputs. So transactions have inputs and outputs, and outputs can be spent or unspent. So if I go a bit back here, right, this point, sorry, one bit more here, right. So this is, let's say, the state we have right now. So I mean, of course, it's only a small snap. I mean, a small part of the whole blockchain. So we are only looking at Alice and Bob. Let's say Alice has one output, unspent output of 100 ADA. You can think of that like a coin in your wallet. So it's this one entity. So this is like an output that's a coin that's worth 100 ADA. And it's called transaction output because it's the output of a earlier transaction that's not in this diagram. So Alice has 100 ADA and Bob, for example, has 50 ADA. And now Alice wants to send 10 to Bob. As I said, if this was Ethereum, then we would just update and say, okay, Alice now has 90 and Bob has 60. We would update the balances. But in the UTXO model, if we now do a transaction, let's see. Right. So Alice would create a transaction. Transactions have inputs and outputs. It can be arbitrarily many inputs and arbitrarily many outputs. Inputs are always until now unspent transaction outputs. So Alice can use this unspent transaction output as an input for this transaction. By doing so, it's no longer unspent. So this output, which was unspent, by using it as an input for a transaction, is now not spent anymore. And it can have outputs. So she wanted to send 10 ADA to Bob, so she can do that. So she creates one output of 10 ADA for Bob. And now, of course, she put the input was 100 and the output is 10. So what about the difference? Well, for that, she can create a second output, a so-called change output, back to herself of 90 ADA. I mean, this is cheating a little bit because there are also transaction fees. So the sum of what goes out is slightly lower than what goes in due to transaction fees. But that's basically what the transaction looks like. And the effect is it removes certain UTXOs. So it spends formerly unspent outputs and it creates new unspent outputs. So the point is nothing gets modified. I mean, the outputs themselves never get modified. They are like similar to a list in Haskell or a map in Haskell or anything. So nothing ever gets modified. The only thing that happens, that the effect of a transaction is to spend some UTXOs and create new ones. So in this simple example, so this is how on Cardano or also on Bitcoin, Alice would send 10 ADA to Bob. So she takes one or more, of course, I mean, in this case, she had one coin that was big enough. There, of course, also, okay, I think there's an example now. As I said, there can be more than one input. And then, of course, somehow, I mean, if anybody could create this transaction, then anybody could steal Alice's money. So to prevent this, the transaction must be digitally signed and it needs a signature, in this case from Alice. Actually, it needs a signature from basically every owner of an input. So in this case, the only input of the transaction belongs to Alice. So only Alice needs to sign this transaction. That guarantees that only Alice can spend, that only Alice can spend UTXOs that belong to her. Okay, and I mean, here I say Alice and Bob, but of course, in reality, this is addresses on the blockchain, which, as I mentioned earlier, is hashes of public keys, more or less. On Cardano, it's a little bit more complicated because Cardano also has staking. So addresses actually on Cardano have two parts, payment part and the staking part. But I think for today's lecture, that's irrelevant. So we don't have to worry about that too much. So you can think this Alice is just like a short form now for actually the hash of Alice's public key. And that identifies, that's the address where this UTXO sits of worth 100 ADA. So this UTXO has an address, which basically says to whom it belongs, and a value, which in this case is 100 ADA. And then if you want to spend such a UTXO in a transaction, that transaction needs to be signed by the owner of that UTXO, basically the owner of the address. So far, so good. And I think there's a second example. Right. So now let's assume that Alice and Bob together want to pay 110 ADA to Charlie. So 55 each. So here we have a transaction that's a bit more complicated. So in this case, so Alice only has one UTXO. I mean, she had this one, and then the transaction one spent that one and created a new one, the change output. So she uses this as an input for transaction 2. Bob has 2 UTXOs at this moment. So the 50 he had from the beginning, and the 10 he now got from Alice. So in order to pay 55 to Charlie, obviously each of those 2 would be too small. So he has to use both of them as input. So we get a transaction with 3 inputs, 1 coming from Alice, 2 from Bob. And then there's enough money to give the 110 to Charlie. So that's 1 output of the transaction. And then there are also, in this case, 2 change outputs. So Bob paid 50 plus 10 into the transaction, wants to give 55 to Charlie. So 5 change. That's this change output. And Alice paid 90 in and wants to pay 55 to Bob. So that's 35 change. That's that output. So that's basically how, I mean, yeah, how the UTXO model works. Are there questions?
Yeah, Lars, we have a question. Tony asked, what does the E in UTXO stand for? And how does Cardano marks a transaction as spent at database?
Just a second. Is that in chat, the question?
Yeah.
Let me just read it. Okay. So the E, we come to the E. I first wanted to explain the UTXO model without the E, just to basically give a crash course in how that works. And then the E is basically where smart contracts come in. So the E is an extension of this to allow smart contracts. So in the second half or second part of the lecture, we'll talk about the E. And for the second question, very good question, actually. So the nodes themselves, in principle, only store the set of UTXOs. So the node would, I mean, the state of the node in the beginning of my example would have these 2 UTXOs, Alice and Bob. And then when transaction 1 comes in, it would update that set. So it would remove this UTXO from the set and add those 2 outputs here of the first transaction to the set. So now it contains of 3. This original one from Bob, this new one for Bob, and this one from Alice. And then when the second transaction comes in, it would remove those 3 and add those 3. So the nodes basically only keep track of the current UTXO set. And now, I mean, you asked database. I think actually the UTXO set is in memory, but of course, I mean, it's also serialized on disk. So somehow that it's on hard drive. So always the UTXO set is on disk. But I think the node in principle doesn't remember the past. So it only knows, I mean, of course, the information is all there. So somewhere on the hard drive are basically all the previous blocks from the Genesis block. But the node can't really look that up. So the node, each Cardano node, only aware of the current UTXO set, more or less. But there are additional tools. One is called dbsync that indeed feed a database. So you can basically set up dbsync for if you and connect it to a Cardano node, and then you end up with a database that has the whole history of the blockchain, and you can query it with SQL. You can ask for, I mean, also for past UTXOs and so on, and all transactions that ever happened. But the node itself, I mean, strictly speaking, you don't have to remember that. So the node only knows the current UTXO set. And then when a new transaction, a new block comes in, it basically updates the UTXO set. It removes the spent outputs and adds the created ones. Does that answer the question?
Yes, Tony say thanks.
Welcome. Okay, so now I think we can do a demonstration. Are you ready, Karina? Do you have an address for me?
Yes, I have the address for preview and pre-pro. Let me send
pre-prod,
you.
please. Can we
Yeah,
use pre-prod, please?
Yeah.
Okay. Will you send it in the public chat or?
I send you in the private.
Yeah, perfect. Thank you. Okay, so now let's say I want to, let me just copy this. Right. Now let me switch to, what do I want to switch to? I think to here. Great. Maybe not. Oh no, sorry. Never mind that. Yeah, sorry. Probably have too many windows open. Let me just switch to.
Actually, I can send in the
Oh, no, it's fine.
global
I
chat.
have, I have, yeah, you can. I have,
Yeah.
yes, you can do that actually.
For
But
the guys can check that there are
yes,
no money
yes,
in
yes.
my wallet. Can check in pre-prod.
Okay.
Yeah.
So, sorry, just sorry. So I'm. So now you. I mean, if you want to, like, I mean, there are various ways to do this. I mean, you can do it by hand, basically. But there are also so-called wallets that make things like that easier. And there's this one. So at the moment, I have 8,305 test ADA in this one. And now I can send 100 ADA to Karina. So, I mean, this is the so-called NAMI wallet, and something went obviously wrong right now. Never, no idea why. Okay. So I paste the address in that she shared, and now I can type an amount, example 100 ADA. This assets thing, I mean, we will talk a bit about that later today and also during the next 2 weeks. So Cardano has so-called native tokens. That means, I mean, there's ADA, that's the native currency, but you can also create new currencies on Cardano. So as I said, we'll talk about that definitely next week, how to do that using Plutus. But so basically, I mean, it's not important really how it works right now. Just there are other currencies on Cardano, and everybody can create them. And then once they are created, they behave exactly like ADA. So we can, in particular, send them to somebody else. But right now, let's just do ADA. So if I want to do that, I can send. And now I need to, I mean, as I explained before, this transaction has to be signed by my private key. So the wallet is aware of my private key. And does the signing for me. And I just have to, I mean, the wallet just asked me when I set it up to define a password so that if I leave my browser open, for example, then nobody can basically, while I'm not there, use my wallet to send money somewhere. But this is, I mean, this password is not I mean, the private key is what actually now will happen. Okay, so now I submitted it. And I can now here the transaction history and transactions on Cardano. I mean, there's a block on average every 20 seconds. So on average, it will take 20 seconds until the transaction goes through. But because it's only on average, it can be faster, but it can also be slower. So sometimes you have to wait a minute or so. Sometimes it's only 10 seconds. So it depends. I just want to wait until this is true. Okay, now I think, yeah, sorry. Open it again. Right, now here my wallet shows that I paid 100 ADA, and there's also fee 0.17 ADA. And if I open that, I also get this transaction ID, and the transaction ID is again a hash. So the transaction is hashed, and this is then used as identifier for the transaction. And now I can also use a so-called blockchain explorer. So that's third-party tools that people have created to make it possible to find something on the blockchain. And for some reason, it now doesn't find the transaction. Maybe because it's not there yet. Let me just refresh.
Yeah, but
okay, now there it is.
yeah, now.
And
actually, in my
this,
wallet, I have in my wallet now.
you have it.
Yeah.
Okay, cool. Right. Maybe yes. Maybe you can also share. But just wanted to say, so the Cardano scan is one of the blockchain explorers that people have written for Cardano to check what's going on. And here we see we are now on the pre-prod testnet. So Cardano scan supports the mainnet and this pre-prod testnet. And so here we can now look at details of the transaction. So the transaction hash, it's in which block it is. Cardano has these epochs that last 5 days. So this is timestamp, the fees I paid, maybe I can make it bigger, 0.17 ADA. Oh, this is also interesting. Total output 5,486. So we'll look at that in a second. That sounds a bit weird, right? And here summary. So from my wallet, I sent 100.17 because of the transaction fee. And this must be Karina's wallet, so she received 100 ADA. But now we can also look at UTXOs. And there we see that actually I used like 1, 2, 3, 4 inputs. So in my wallet, I mean, that's up to the wallet to construct this transaction, decide what inputs to use. So my wallet decided to use these 4 UTXOs that I had in my wallet. They are here all identified by the addresses and the transaction hashes that created them. Yeah, that I should also mention. So UTXOs are always identified like this. So it's a transaction hash, then the hash symbol and an index. So if we go back to here, for example, to identify this UTXO here, one would take the transaction hash of this transaction, and then the outputs are ordered. So it starts at 0, and then, so this, for example, could be output 0, and this would be output 1. So then this UTXO would be identified by this, the hash of this transaction, hash symbol 1. This would be, this one here would be hash of this transaction, hash 0. Right, so we see there are these 5 inputs. Was it 5? 1, 2, 3, 4. Sorry, 4 inputs and 2 outputs. So no, 3. Sorry. So this is the one for Karina. So this is the output goes to her wallet, and then there are 2 change outputs, both going back to myself for whatever reason. I mean, the wallet decides. And I mean, there's no clear-cut rule. So it could also have used 1 change output and meshed those 2 together. And now maybe if you like, Karina, you can share just briefly what it looks like from your side, if you like.
Okay, let me share.
Do I have to? Yeah, I stop sharing. Can you share? You have the right to share?
Yes, I think I can share. I don't know if I have the correct rights to share, but because
I mean, for me, it's between the, it's to the right of the chat button at the bottom.
I only have the whiteboard and use system desktop capture. It's the only things I have to share.
Oh, desktop? Do you have desktop?
No, I don't have desktop.
Anderson, who give her the rights?
Yes, everyone has a right to share.
Oh.
Let me see. Yeah, anyone can share the screen.
Everybody can share? Okay.
Yes.
Okay, I need to. Okay,
I mean, it's fine.
Let me
I mean, it's
only
not important.
leave and then, yeah.
Yeah, okay. Right. Yes, you can share. Okay, Karina is back.
Okay, I'm again here. Okay, no. I don't know why.
It's only whiteboard, you say?
Yeah, I can share. It's
Strange.
a little strange. Yeah.
It doesn't matter.
Okay.
I mean,
yeah, got it. Right. I think now.
yes, now I can see your screen.
Okay.
Yeah.
Yeah. Okay. This is my wallet. I am pre-approved, and this is the amount. Lars said
What wallet is that? Is that Lace or?
It's Lace, yes.
So Lace, I should, of course, it would be more proper to use Lace because Lace is the IG wallet, but I'm not used to that yet. Okay, so you got, and there, can you also, yeah.
Yeah, I received.
And if you click on this receive, then probably you will also see the same transaction hash. Exactly.
Exactly. This is the transaction.
And this is a different, this is also good. So I was showing you this Cardano scan, and it seems Lace uses the C Explorer. So that's a different Explorer. So written by different people to explore the Cardano blockchain. Okay, so this is, it looks different, but it should, of course, contain the same data. So particularly the same block and slot and all of that.
Exactly. Yeah.
Mm-hmm.
Okay.
Nice. Okay, thank you very much, Karina.
You're welcome.
So, okay. So then I think I briefly explain now the UTXO model, and then we can have a short break, and then we can do Marlowe on Cardano. Can you stop sharing, please? Thank you.
Yes.
Let me share again. Thanks, Karina. Okay. Where was I? Here. Right. So this is the UTXO model. So that's how Bitcoin also works. Only except Bitcoin uses obviously Bitcoin instead of ADA. But same principle. And Bitcoin actually also has smart contracts in a very limited form. But right. So now to answer this earlier question, what the E means. So E stands for extended. So our scientists at IOG, wanted to come up with a way to do smart contracts on Cardano in a way that plays well with the UTXO model. I mean, the first blockchain that had proper smart contracts was Ethereum, but as I mentioned before, Ethereum uses this account-based model. So smart contracts work completely differently there. And our scientists came up with a way to extend the UTXO model to do smart contracts. So that, yeah. And so let me see. And the idea is, what do we want to extend? Let's just recap the data that in the UTXO model that one such output contains. It's basically just an address. So here it's called Alice, but as I said, that's the hash of Alice's public key and the value, which in this case was 100 ADA. And so that's one part, the data that's contained in this output. So an output has an address and a value, and the condition which allows a transaction to spend that output. And that condition is, as I explained, that the transaction that wants to spend this output needs to be signed by the owner of this address. So signed by the private key, where the hash of the corresponding public key is this address. So that's UTXO model. So the data contained in an output is address and value, and you can spend an output by signing the transaction with the corresponding private key. And now the idea of extended UTXO model is to replace this address with a script. And for the moment, it doesn't matter. I mean, will be Plutus, of course, the programming language the script is written in, but for the UTXO model, this doesn't matter. You can just think some program. And to replace the signature, if you want to spend this with some arbitrary piece of data, that's called redeemer. So basically, the E extends the UTXO from, just where the addresses are just hashes of public keys. Now they can be scripts, or rather hashes of scripts. And signatures get replaced by arbitrary pieces of data. And the way this works is now, earlier, if a node wants to validate a transaction and check whether a transaction is valid, it does all sorts of check. For example, it checks that the sum of input values equals the sum of output values minus fees, things like that. But then it goes through every input of the transaction and checks whether the signature is there. So if an output belonging to Alice is spent in the transaction, the node will check, when it checks validity of transaction, that the transaction is been signed by Alice. So it does that for every input. So now in the extended UTXO model, if there's not an address, but a script, so-called script address, then what the node will do, it will execute the script, and as input, it will get the redeemer. And then the script can contain more or less arbitrary logic, and then basically answers yes or no. Yes, it's okay to spend me. No, it's not okay to spend me. So that's the idea, that the plain UTXO model, for an input, node checks whether the transaction is signed by the owner of the input. And in the extended UTXO model, the node executes the script, and as input, that script gets the redeemer. And then the script can say yes or no, it's okay to spend me, or it's not okay to spend me. But this is not all. So the next question is that, this is basically how Bitcoin works, sort of. Now the question is, this wouldn't be sufficient to do very interesting things if that was all that the script would. If all the script gets as input is the redeemer, then you couldn't do very interesting things. So the question is, what should the script get additionally as input or as context? So how much or what big part of the blockchain should the script see? So one option would be the Ethereum option, where Ethereum scripts in principle have access to the whole blockchain. So they have a global view of everything. So an Ethereum script can in principle query everything on the Ethereum blockchain. So that's supposed to be indicated by this image. Or you could do it, as I said before, where you can basically just see the redeemer. But actually what Cardano does is
Sorry, guys, I think
think you logged off.
Yes, I was thinking was me, but no. I think Lars have some problem with
Okay.
his connection. Let me let him know.
Okay.
Yeah, yeah. I think it's a good time to have a
Hello.
break.
Sorry.
Okay.
Yes,
Lars.
sorry. Suddenly my screen froze and I had to restart my laptop. Sorry about that. How long did you hear me?
I think about the 5 minutes, 3 minutes ago. When
I mean, what was the last thing you said?
you are explaining about the let me Samsung. I think we have a question. Sorry, Lars, we have a question for Samsung.
Of course.
Go ahead.
Go ahead,
please.
Samsung.
Sorry, you were saying that Ethereum could query anything on the blockchain, and then you cut off.
Okay.
Yeah.
Okay. Then maybe let me just finish that explanation about the EUTXO model and then we can have a short break, okay?
Yes.
Thank you, Samsung. Okay, let me share again. I have no idea why suddenly everything froze and that was that. Okay, let's see. Okay, right. So I was saying, I mean, so there's this, I mean, one choice would be that basically it's a very restricted view. The script can, sorry, that's not the script yet. There we go. That the script can only see the redeemer and nothing else. That's the choice that Bitcoin made. And then the other extreme would be global view like Ethereum does. So the script can see everything, the whole blockchain. But actually Cardano chooses the golden middle. So the script can see the spending transaction. So we are in the context of validating a transaction. So Node tries to validate a transaction. And by what it does is it goes over all inputs of the transaction and validates them. So if it's a normal input, a public, so-called public key input, I mean, or where the address is a public key address, it will check that the transaction is signed by the owner of the public key. If, however, it's a script address, it will execute that script. The redeemer will be an input to the script, but also part of another input to the script will be this transaction that's currently being validated, including all its inputs and outputs. So the script, when it runs and decides whether it wants to say yes or no, valid or invalid, it can, I mean, it has access to the redeemer, but it also has access to all the outputs of the transaction, all the inputs of the transaction, and also some properties of the transaction itself. For example, the signatures included in the transaction. So in particular, this is I mean, one could generalize, I mean, the normal behavior for public key addresses where just check that its transaction is signed, one could do that with a script as well. So in that case, the script would just check that a certain signature is present. And this is almost all. And there's one ingredient missing, and this is so-called datums. So there's one more part to the E in extended. Earlier I said an output has an address and a value. And in the extended UTXO model, additionally has a so-called datum, which is an arbitrary piece of data. And that's it. That's the extended UTXO model. So the extensions are that instead of just public key or pub key hash addresses, we can have these script addresses. then instead of just having signatures in the transaction, we can have these redeemers, which are arbitrary pieces of data. And we have this datum attached to an output, which is an arbitrary piece of data. And then validation works that the script, if it's a script input, then the script is executed, and as input, that script gets basically the whole transaction, the redeemer, and the datum. And using those pieces of information, it can decide whether it's okay to spend this script in this, this input in this transaction or not. And that's it. And then you can, for example, mathematically prove that with all of this, you can do everything. I mean, it's equally powerful to Ethereum smart contracts, for example. So everything you can do on Ethereum, you can also do in this EUTXO model. But it's a very different, so a lot of people that have some experience writing Ethereum smart contracts find it challenging in the beginning to write Cardano smart contracts because the programming model is so different. I mean, you have to get used to this UTXO model and this local view. But there are very cool advantages to this. So for example, I mean, the context is very limited. As I said, on Ethereum, you see the whole blockchain. A Cardano script only sees the spending transaction, which also means, I mean, far less things can happen. I mean, the situation is much more, much smaller or easier in principle, because, I mean, you only have to worry about this one transaction. And it also means that everything is deterministic. So on Ethereum, when you submit a transaction, you can't know whether it will succeed or not, because while basically the transaction is being submitted, somebody else can have done another transaction concurrently, and that can have changed the state of the blockchain. And then depending on that, maybe your smart contract fails or succeeds. So you don't know in advance. So in particular, it can happen on Ethereum that you send a transaction and then it fails, and you have to pay transaction fees or gas fees. And on Cardano, because of this what's about, I mean, that nothing changes, that there's no modification of state, you know exactly whether, I mean, what the result of the script, running the script will be. So you don't, I mean, yeah. So you know before you even submit a transaction whether your script will say yes or no. And of course, something can still happen in transit. So somebody else could spend an output you try to spend. But that's basically the only thing that can go wrong. So provided that all the outputs you want to spend in your transaction are still available when your transaction gets validated, then the result of validation is deterministic, because either the outputs are there or not. If not, then the transaction fails anyway. But if everything is still there, then you know exactly the situation that, because nothing can change. Nobody can modify anything here. I mean, all transactions can do, as I explained, is spend outputs and create new ones, but they can't modify existing ones. So you know exactly what, I mean, the situation these scripts will run in. I mean, you know exactly what inputs those scripts will get. So you can locally check whether your transaction will succeed, provided all the inputs are still available. And therefore, on Cardano, don't have to pay anything if a transaction fails under normal circumstances. So if you don't go out of your way to punish yourself, then you never have to pay for a failing transaction, and you always know in advance whether your transaction will succeed or not. Exactly, as I said, it can still happen that inputs are gone and then it fails, but you don't have to pay for it. But if all the inputs are still there, then it will succeed, because you know exactly what will happen, because you can do that locally without ever submitting it. Right, and that's the idea of the extended UTXO model. And scripts are written in a programming language called Plutus, which is very similar to Haskell, which is one of the reasons why we spend so much time learning Haskell, although not the only reason. I mean, Cardano anyway is written in Haskell, so the Cardano node is written in Haskell and so on. Nevertheless, but it's very simple Haskell. So that will be a walk in the for you to understand Pluto scripts. It doesn't use any fancy features. In principle, I think after 1 week of Haskell, you would be able to understand Plutos. And but I mean that we will start talking about Plutos next week. So today we want to still talk about Marlowe. And Marlowe is, Marlowe uses Plutos. So there is basically the script in question is basically Pluto's interpreter of Marlowe contracts. And the state of the Marlowe contract is encoded in this datum. And each time something happens, so for example, if you recall Marlowe, we wait for these external triggers, like somebody making a deposit or somebody making a choice.
Lars,
So each of the, yes?
I don't know, only me, but I think okay, sorry. I think it was only me.
Oh, okay. Just want to say, so each time something happens, like somebody makes a deposit in the Marlowe contract or a choice, that would correspond to a transaction. So the Marlowe contract is represented by a UTXO. The state of the Marlowe contract is represented by the datum. It doesn't matter that's encoded. Somehow so the contract knows basically what state it's in, so what it's waiting for next. And then if somebody is, for example, making a deposit into a Marlowe contract, that would correspond to a transaction that would consume the UTXO represented contract, having a new output again at the same script address with a change datum and maybe a change value. So the change datum would represent the updated state of the Marlowe contract. The change value, if somebody makes a deposit, then would be that. So we will look into that after the break, practical example. But so that's the idea. And that is also the idea how you can basically do, as I said, in Cardano, nothing ever changes. So this datum here will never change. But in order to do something, to do a stateful thing on the blockchain, what you do is you consume a UTXO and recreate one at the same script address with an updated datum. So it's similar to how you do Haskell, how you modify a Haskell data structure. You never mutate in place, you always basically create a new thing. Like if you update, if you insert into a map, for example, in Haskell, the old map is still around and you return a new map with the inserted element in it. And same is how these smart contracts work. So you wouldn't modify this datum, you would consume it in a transaction and recreate a new output with a different datum. And this is also, it's one of the reasons why Haskell and Plutos and UTXO model go so nice together, because somehow this just matches how functional programming languages, in particular Haskell, does, things about data and works with data. You don't change in place, you basically create something new. So therefore this is all goes very well together. Okay, are there any questions at this point?
I think so far there are no questions.
Okay, then I maybe break until past, and then we can take a Marlowe contract and execute it on Cardano.
Yes.
Awesome.
Okay, thank you. Okay. Right. So now, let's look at Marlowe. And if I Google Marlowe's starter kit. So there's a very nice repo called Marlowe starter kit, which has lessons how to work with Marlowe. And the nice thing is to provide Docker images and various ways how to actually interact with Marlowe, so that all the tools you need will be installed if you use their Docker image, for example, and there are nice instructions how to do that. And what we want to do for this course is basically we clone this repo and make it part of our GitHub repo, and then you can easily you follow the instructions in here, go through everything. So let me just switch to, unfortunately my computer crashed earlier, so now I have to run that again. I hope it won't. So I basically followed those instructions yesterday and set, or maybe for yesterday, and set everything up. So I now just have to do Docker compose start, because I already, and I must specify the network. So I can quickly get started. So this Docker, why is it only 3? It should be much more. So should be 8 or something. It must have. Robertino, do you know what I have to? I mean, until now, when I did Docker compose started, always started all 8 services, but now it doesn't for some reason. So I don't know. Just stop it again. I don't really know much about Docker compose, so I just followed the instructions. And until now, it always worked. And there are supposed to be, I think, 8 of these containers with all the various tools one needs. But for some reason, now it only started 3 of those. Because the
I
others
think
were,
when you, I think the first time when you run the Docker Composer started some containers, but
yes, it seems the others
give
were
you,
already were still running for some reason. But
Yeah.
that's good, I suppose. So let me just stop everything and start it again. Hopefully then it works. So you will be able to, if you just follow the instructions, I think it's here in docs, Docker. So I basically just followed these instructions to get to this point. And now hopefully all 8 will start, or 11 actually. So if you use this, now the other stuff. So perfect.
They can also use Demeter in case they don't have enough resources.
Right. So there, I mean, this Docker is only one way. So there's also here, there's this Demeter run. So that's a hosted environment. So basically all you need is your browser and all the tools are there. And there's also a free tier. And I think if you don't use it too much, then it's basically free. And you can use that in your browser if you don't have enough resources on your laptop to run this Docker these Docker images. But these basically install all the tools, make all the tools available you need. In particular, also a Cardano node for the preprod network in this case. I mean, it would also work for mainnet, but for mainnet, you would have to wait a long time for the blockchain to synchronize. So preprod, and of course, it's real money. But with preprod, it's much faster. So this starts a Cardano node and all sorts of other tools so that you can work with it. And in particular, it installs or makes available Jupyter notebooks. And then, where is it now? Sorry. So then you have these Jupyter notebooks, and there are lectures. So actually this lottery stuff I added, but this 1 to 8, that's basically what's in the starter kit. And then they have very nice explanations how to do this. So there are various walkthroughs. And if we look at the list of lectures, sorry. I mean, the first 3, they basically show 3 different ways in this environment to run the same contract. So there is one tool called Marlowe Runtime CLI. That's the first lesson. Then there is REST API. So that works with the web server, which also is set up by the starter kit. So everything works, everything is up and running. And thirdly, they have something called Marlowe CLI, which is a bit more low level than the Marlowe Runtime CLI. But with all 3 methods, you can do the same thing and execute a Marlowe contract. And everything works. I mean, I went through these first 3 lessons last night, and everything works perfectly. So I thought I just do this now in the lecture, go through these things or some of those, but somehow I think that's maybe a bit boring. I mean, everybody can do that. I mean, you can do that yourself. You don't need me for that. So I think it's maybe better to do like another contract, maybe the one we did as an example on Monday, so that there's a different example. And I also don't think it makes sense to do all 3 things, because I mean, they are very similar. And I mean, I wouldn't be able to remember that anyway. I mean, if you actually want to do this for real, then you have to like read the documentation anyway. So I think I'm not sure, but I think the runtime is maybe the most convenient one. So I think we should use that. So question to Karina and Robertine, do you think we can pull it off to do this like with 3 parties together? If I share like the contract ID in the chat and so on? Or is that too challenging and I should do it myself?
I think we should try. For my,
Yes.
yeah. I don't
Okay.
have that lottery CLI though.
Yeah, that's fine. We can share all of that, right?
Yeah.
Okay, and then okay, so that's that. So let's go back to the playground. And okay, and let's do a new project. And let's just copy the example from last week. Sorry, from Monday. Sorry, just get to that. So this is now something we have never tried before. So all is live and it can be embarrassing, but I hope it will be fun. Right, so let me first of all do this. And before we do anything, let's just try again how it works. I mean, lottery is probably maybe not a good name, but anyway. So the idea was 2 people can pay into the contract, and see, so this be after the other one. So the amount, say 100 ADA. So Alice and Bob can pay. So if both make their deposits of 100 ADA, then Charlie, the third participant, can pick one of the 2, for example, Bob. And then whoever he picks gets all the money. I mean, that was what we did on Monday. And I mean, it's written in Haskell, so it was configurable. Right, so we could also do more participants, but seeing as Karina, Robertino, and myself are 3, I think leave it like this. But now we can, I mean, that's the way it was written, so we can use different things here. So now the first question is, I mean, there are 2 ways. I mean, I explained about these parties. So parties are the participant to a contract. And I mentioned that last week, and we can also, sorry, we can also see it in Blockly. Can we see it in Blockly? I think this way we can't see it in Blockly. So let me just, sorry, just want to show Blockly again. Don't save. Here, this party thing. So there are 2 ways. I always use this one, role, and then I gave a name like Alice, Bob, and Charlie. There's also the address option. So address means I would hard code a Cardano address. And I mean, that's simpler, but then of course it's less flexible because then, I mean, it's hard coded who the participants are. The second thing is with the role, works with NFTs. I mentioned Cardano native tokens before. So there are, I mean, everybody can mint their own currencies. We will look much more detail next week how that works. But there's a certain class of tokens called NFTs, non-fungible tokens, and they have the property that there's only one coin in existence ever. So it's a unique thing. So I mean, you can make your own currencies, whatever. You could make the Kenya coin and have whatever 100 billion of those. But you can also make custom currencies where there's only one, and such are called NFTs, non-fungible token. And they can be used for various things. I mean, for example, artwork, people like create digital art and link it to an NFT, and then they sell it, and people can buy that and trade it and collect it. And it can also be used for like administrative stuff, like in this case for Marlowe. So this idea of this role is there will be NFTs, 1 NFT per role, and whoever owns that NFT can incorporate that role. So if there's an Alice role and I have the Alice NFT, then I can play the part of Alice in the contract. And I could even like send my Alice NFT to somebody else, and then that new owner of the NFT could participate in the contract in that role. So the first question is now for the demo, should we use hard-coded addresses or NFTs or both? I mean, we can also mix it. That some people, any ideas?
Let's mix it just to showcase it, or?
Yes, okay, right. So, oh no, I think I'm a bit worried that my laptop will crash again. Anyway. Okay, let's do this again. Okay, so then let me do Alice. No, let's call us Lars, Robertino, Karina, party, and we'll use, I don't know, Lars, Robert, no, let's do it like this. Robertino, Karina will be the one that put the money down, and I decide who gets it. Okay, now, okay, fine. So let's say I use NFT that I call Lars. Robertino also used, sorry?
I just shared my address if you need it in the chat, just in case.
Okay, great. Okay. Okay, thank you. And I think Marina shared her address earlier somewhere, but I don't see it anymore. Okay, fine. Then Robertino is the address, and I assume I can just say, is it Is the constructor address? No. Account, I think. Does anybody know what the constructor is called?
Don't recall, but I can look it up quickly.
Probably not account. Account is something else. Just maybe it also works with overloaded strings like this. Let's try. That's the reason why last time I did it locally, where I could use the REPL to ask for like constructor names and stuff. Okay, I think this works fine. So that uses overloaded strings. So I hope that means, or is that now also role? So I don't know. Maybe I should just check again.
In the language, it's called address, but
Address. Okay, let see whether that compiles.
no.
What says oh, it's
Add-
applied to.
A few arguments.
Can you check what address? Maybe it needs a staking part or something. Just try to see. So what was it called? Marlowe Cardano. Let's check. Marlowe source language Marlowe or semantics types. Okay, party is there somewhere. Payee. Okay, network. We need network.
Oh.
Okay, and and what is network? Yeah, I think I need to. Sorry about that. Let me just start another. Sorry, yeah. Because then I have to REPL and everything.
Yeah, I mean, we don't usually use this because like hard coding the address is not ideal.
Exactly. But yeah, I mean, as you said, I mean, for variety, it would be maybe good to demonstrate that, but okay. That was called Marlowe, I think. It's not. Okay, fine. So okay. Great.
I think pub key, the constructor pub key.
Ah. there's a constructor.
Yes. I mean, it's same as in like the role, but if you call it pub key, then it takes a pub key hash and maybe overload the string will work.
Ah, and where is that defined?
In data party. Let's see. Not sure where is defined. Let me see. Semantic types. In semantic.
Okay.
Yes. Language Marlowe core v1 semantics type. There. And there should you should find the I think it no. Okay, that's
Okay. I mean, I suppose. I mean, I could. And we can also just go with the NFTs, but I mean, it's not clear what. This network bool is of course also a bit silly. I mean, it's not clear whether mainnet is true or false.
the right mainnet value. It's a boolean.
Network is a boolean. It's a bit stupid. Let's see. Okay, okay, fine. There they have defined mainnet testnet. Okay, that's good, at least. Okay, anyway, okay, fine. Okay, deserialize address. Okay, here. This is what we want. Deserialize address back 32. Back 32 is this this format that Robertino and Karina were pasting. So we have deserialized address back 32, and now if I need overloaded strings for that, now I can do deserialize address back 32, and I can paste this address in, and there it is. So that was Robertino's address. Okay, so that I can do. So let's go back here in the playground. So I can do deserial. What was it? What was okay? English spelling. Yes. Back 32. Let's see whether that works. No.
Do you have to import it?
Yeah, probably. Otherwise, I can, of course, also. What's that now? Language Marlowe 4. U1. Semantics. Okay, that's a maybe. Okay, fine. maybe address anyway. So Latino address type address and just Latino address is this thing. I need my Vim bindings, otherwise I'm totally useless. See whether that works. Fine. Sorry. Sorry. Let's just drop. They don't make it easy, do they? Hmm. Okay, that took a while. Sorry about that. But it would be bad if we got that wrong, because then we have to do it all over again. Okay, so there are two ways of specifying parties in Marlowe. One is with a specific address, and the other one is via these NFTs. So now we have this, and I wanted to demonstrate both. That's why for Robertino I used this. And this string format, this is called, I never know how to pronounce it, batch 32 or back 32 or bech 32. But anyway, that's like a common format that is used by explorers and so on to specify Cardano addresses. And you can see so that it's an address, and test that it's a testnet address. So mainnet addresses wouldn't have this test here. Okay, so now we have this.
We have a question.
Yes.
Can we use the owner and pass it the address? I think I'm not sure the question. I think the question is, can we just copy and paste the address to the owner and that's it?
Nope.
Can you read it? Yeah, can you read it in there? Because I'm not sure if
Yes, yes.
Yeah. I mean, owner.
No, owner is owner. No, I think the only two constructors of this thing are address and role. Party
Yeah.
only. Party only. I mean, that's here. If I looked, so if I ask for party information on party, there are only these two constructors, role and address. And address takes network and this Pluto's address, and role takes a token name. But token name implements is string, so therefore we can just write something like Karina or Lars. I think actually Pluto's addresses also take, not sure. That's always a bit confusing. Anyway, right. So that's our contract. So we can send it to simulator again. Now this is also a bit weird because this time updates to the current time, but those don't. So I must do that manually. 10. Okay, so this is now Robertino, and this is all a bit strange, but nevertheless. So if he does it first, and Nina, and the winner is Okay, fine. Okay, so that's the first. So I mean, this is now the simulator. Now the next thing we would do is download that as JSON. But we must get our, we must set our parameters here. So, 100 ADA is fine, I think. For the times, I should be much more generous because I don't know how long it will take us. So at least like 1 hour, I'd say. But we should manage. But it doesn't matter. I can also put 5:30 and 5:45 or something. Or 50. Doesn't matter. Just in case. Hopefully we won't take that long. And I should also add that this will maybe now be a bit off-putting for you because it's like very complicated. But you must keep in mind that this is, I always believe one should first learn the basics and do it by hand something, and then later you can automate it. And of course, nobody would use or step through a Marlowe contract like we do it now. It's very low level. Obviously, you would have an app or something with a nice UI that hides all these details. So in practice, it wouldn't be so horrible. Okay, and now I can say download as JSON. And this is now downloaded, so will be somewhere on my machine. Downloads. This is this one, I think. So just checking. Okay, so this is now the contract in JSON format. And we see here's Robertino and then Karina and Lars. Okay, so that's the right one. Let me just name that to lottery contract. Okay, fine. So now I can close this. I don't need that anymore. So we are done with Haskell now for this lecture. Because now we have our contract in JSON format. So now let me, I prepared some notebooks. This is now, it was for a different contract, but nevertheless, I will use this notebook now as a guideline for me. Right. And okay. Sorry, I have this open twice. Just this again. So this is now a Jupyter notebook. So the first thing, and I think Karina and Robertino, to get these things, you don't have keys and stuff. So let's see how to do that. I'm sure we'll manage somehow. So let me first start and deploy the contract and then worry about how you participate. So I must execute this. This just sets some, so this is all Bash. So it's Bash in an environment where these tools are available, the Marlowe specific tools, in particular these tools here. Right, so far so good. Now, this was specific to other people, but I can at least send myself, and I can, so let's say Lars Eski. So I prepared, there's this in the same, sorry for jumping back and forth, but here's this setup folder in the Jupyter notebooks, which is part of the environment. And there's this local environment and setup keys. So I did this first to generate keys for myself. And there's also explained how you can get test data, and all of that is in there. So I went through that already. So in particular, I set up, generated a private key that was called lender key. So let me now call it Lars. And I now use the address, lender address, Lars address. I can execute this. Okay, and this is my address. And I can now also, sorry, any windows? If I go here, here I'm using a different wallet. So earlier I was showing you NAM wallet. I set up this other wallet, and so there's in particular this lender wallet, and that at the moment has 900 test data. Okay, so I don't have to worry about funds. There are funds in there already. So that's that. So now, because I only play my part, I don't have, so that's now Karina and Robertino, so I don't need that. So far nothing has happened. Nothing Marlowe specific has happened. And this I also don't need because I do have funds. Right. Now, one of the tools that's installed here in the environment is called Cardano CLI. So that has nothing to do with Marlowe. That is a general tool that you can use to do more or less everything on the Cardano blockchain from the command line. But it's very low level. So it's quite painful to work with. But for example, you can create transactions with it, and you can also query UTXOs at a specific address. So I can now, for example, check my address. So this is, as I said, just bash. So this is this address, this one. And I see I have 2 UTXOs. So one and I should also mention, so ADA is our currency, but there's a smaller unit called Loveless, and 1 million Loveless are 1 ADA. So this means this is 899 ADA. And we also, I mentioned before that on Cardano, because it uses the extended UTXO model, each output has address, a value, and a datum, and that we can see here. So the address is my address. So it's not mentioned here again because I was querying my address. This is the identifier of the UTXO, so the hash of the transaction that created it, and the index of the output, as I explained before. And here we can see the values. So in this first UTXO, there are these roughly 900 ADA and no datum. I mean, the datum is empty, basically. And then there is another where I have like 1 ADA and 1 NFT from some prior experiment, and also no datum, or no meaningful datum. Okay, I don't need this. I'm sure there's a, is the DD? I don't need this. Okay, so this should work now. So this just displays the contract that I downloaded from the playground. No, it somehow doesn't. Probably I know I haven't copied it yet. So sorry, that's the old one from a prior experiment. So I must copy it at the right point. Let's do this again. Yes, so now there's no longer Alice and Bob. Now it should, now it's Lars and Karina and Robertino's address. Okay. Now this min Loveless thing, there is one, these UTXOs on Cardano. I mean, as I explained before, each node keeps track of the set of UTXOs on the blockchain. That means that every UTXO costs. because it means there's like some amount of hard drive that has to be used by the nodes to store that UTXO. And everything that causes costs should also cost something. Otherwise, there would be an attack vector on the blockchain. If UTXOs were basically free to create, somebody could flood the blockchain with millions of UTXOs for free, basically, and overload nodes, drive the nodes out of hard drive space. Therefore, there's one rule on the Cardano ledger that the UTXO must always contain a certain minimum amount of ADA. And that is something like 1.2 ADA. So it would be prohibitively expensive to create millions of UTXOs. And here, just to be on the safe side, we use 2 ADA. One could also use 1.5 or something. Must just be a value that's definitely higher than the min UTXO, this minimum ADA that must be contained in every UTXO. Right, and now we can use the Marlowe runtime CLA to create this contract, to basically put it on the blockchain. So first, and all these command line tools, so the Cardano CLI, but also Marlowe runtime CLI, Marlowe CLI, they have quite excellent help system. So, I mean, nobody can, certainly not me, can remember all the commands and subcommands, but normally you don't need to because the help is quite good. So there is this kind of Marlowe runtime CLI create and help, and you see all the options you have. And now we can just try it with our contract. So this won't do anything on the blockchain. It will just prepare a transaction that will then put the contract on the blockchain. Let me just delete this here quickly. Right, so you call create, then the JSON containing the contract, this minimum UTXO that we set to 2 ADA. Change address, I explained before, transactions, I mean, because of the way that UTXO works, one often, I mean, the transactions often send some change back to the creator of the transaction. So I can specify whom that, and seeing as I do this now, I take my address as change address. This just means I will have to sign the transaction by hand afterwards. And this is some bash magic. And this will now result in error anyway. I just wanted to demonstrate that, or I hoped it would result in error. It does. Okay, so now it complains that roles are present in the contract, but no roles currency was specified. And that is, if you recall, we hard-coded Robertino's address, but we didn't hard-code Karina's and my address. So I can, I mean, what I deleted, just, no, that's fine. And we see here in the help that you can specify that this, for example. So we could also give a config file, but we can also do it with command line parameters. So the format is role, and then the name of the role and the address. So for my role, I can do role class equals, and now my address. So class address. Oh, yeah, I think it would be fine because there are no spaces in there anyway, but okay, and now I also need Karina's address. Can you paste it again, please, Karina, in the chat? Because somehow I lost access to your earlier chat, I think.
Yes, I will.
Thank you, Karina.
Welcome.
So, right. So I think it's better if I defined my address here. slow. Okay, right. Let's go back here. So now I have Karina address. So now hopefully this works. Posted it already? Cool. No.
Not yet.
Okay, okay. Right.
No.
So now we have the contract ID already. That is basically used to identify the contract. I can paste that in the chat in a second. So now this is the transaction that we will have to submit to the blockchain in order to start the contract. As you see, it contains quite a lot of data. So now I mean, anybody can start the contract. I decided now to start it, but I mean, Karina or Robertinos could start it as well. And I suppose anybody, I mean, even somebody that's not a party of the contract could start it. So one of you could also start it. So the Marlowe tool here, this Marlowe runtime create basically creates a transaction that will start the contract, but it doesn't submit that transaction. It just creates it. So it's just locally for me now. So now I can use the Marlowe CLI transaction submit command to actually submit this, sign and submit it. So in order to sign it, I must tell it where my secret key is. And I try this and hope it works. And that can, again, take like 20 seconds or up to a minute, depending. And I think this also waits for confirmation. So, I mean, on a blockchain, there can always be so-called rollbacks. So I think this waits until there's like one confirmation, one block on top of the one containing this transaction. So you need to be patient a bit. Okay, so this is now the transaction ID. So I could use that on the Explorer, and this is exactly what this command now does. So it gives me two links. One on the Cardano Explorer Cardano scan that we used earlier when I sent some money to Karina. And right now it's not there yet. Okay. Can try the other link first, but there it is. Okay, so it's a transaction like any other transaction. And as I showed you before, so we can see, I mean, this is the input. So my 900 ADA and the 1 ADA, so both my UTXOs were used as input. And these two, I think, are change outputs to me. And this is now the output that represents the contract. And here this is also change output. So I get my ADA back. And this one here. There are lots of change outputs. But this one is the interesting one. That's the one that actually created the UTXO that now represents the contract. And we see here this icon. That means there's datum attached to this. And I think this item means the smart contract address. So yes, so these two UTXOs were coming from my wallet input. This actually, I'm not sure what that one is. Oh, Karina. Oh yeah, sorry. Right. Okay, so this is a change output. This, I mean, we talked about these role tokens, the NFTs, and in the create, in this, sorry, too many windows. Here, when I created this, when I called Marlowe runtime create, I specified that role Lars should be taken by my address and role Karina by Karina's address. So what this transaction now does is it mints NFTs and sends them to the correct parties. So Karina should now have received a Karina token, and I will have received a Lars token. This one is changed from before. I mean, that you can ignore this. So I already had that. And finally, so this is an interesting output. Karina gets her role token that allows her to participate in the contract. I get mine, which allows me to participate in the contract. And Robertino doesn't get any because we hard-coded his address. It's baked into the contract directly, his address. And finally, this is the output that now doesn't go to a pub key address like mine, Karina's, or Karina's, but goes to the address of this script, of the Marlowe script. So we could look at the script here if we wanted, I suppose, but or not. But here's the datum. So we can see this is now the datum attached to this UTXO. And that is, one can also click on inspect, and then one sees a JSON representation of the datum, but that's also not very enlightening. At least not to me. But somehow that represents the state of the contract. Okay, so that's basically from the point of view of normal Cardano. However, there's a second explorer specifically built for Marlowe. That's called Marlowe Scan. And there's a link here as well. And that's specifically for Marlowe. So it's only for Marlowe contracts, but it gives us much better information. So for example, we see the contract is active. We see in which block it was created, the block header hash, and so on. But we can, for example, also look at the code of the contract. So this is now on the blockchain, contained somehow encoded in this datum. So that's the code. And here there is nothing yet, I think, because we haven't done anything yet. And what I also haven't seen before, but that's, where was that with accounts? Here. Okay, so at the moment there are 2 ADA in this contract. That's just this minimum ADA that need to be in any UTXO. Right, so at the moment, so we have created one, I mean, Karina has gotten her role token, I have gotten my role token. So I could also check in my wallet now. I was this lender, right? So here I see I have like a bit less ADA, and I can click here on token list. And let's see, now I have this last NFT, which I now got. And Karina will have in her wallet a Karina NFT.
Yes, I have.
Very good. Right, and now it's basically, the next step is now that either Karina or Robertino need to deposit their 100 ADA to make progress in the contract. If you recall, when first they have to deposit, and then I have to decide who wins, and then the winner gets the money. So, right, so now I don't know who wants to go first. Robertino? And I of course need to give you help you with the contract ID, for example.
Yes, and
I can also give you the code what you need to do. So first of all, the contract ID. I can paste that in the chat, right?
yes.
Okay, it's the contract ID. And because now, oh yeah, and let me just go on. So I was here. So now there is another command of this Marlowe runtime CLI. It's called log, and it can show the state of a contract. So we see we have created it, and here basically we also see the contract, the full contract. So we don't have to use this Marlowe scan in the browser. We can also just use this command line tool again with the log command. Okay, so now the next step is we want to make a deposit. And so, I mean, Karina or Robertino must make a deposit. And there's also a command for that in Marlowe runtime CLI. It's called deposit. You have to specify the contract ID. You have to specify the party and where it's going. So I suppose, Robertino, in your case, that's then the address, right?
Yes, I have my own address.
Is it? Yeah. Right.
The front part, the contract, I already have the contract ID. The front party will be my own address, right?
Yes, and two party probably as well, because you don't have a name in your contract. I mean, your name is your address, right?
Right. The
And then lovely. I mean, I can, and then change address will also be your own address. I mean, I can copy paste that for you, or do you have that anyway? I mean, I also took that, of course, from somewhere.
Yes, I have it. I have it.
Okay, so maybe you should share your screen then.
Sure.
Now.
Let's see. I just use one that I have previously shared screen. You have to stop sharing. Sorry.
Oh yeah, sorry, I will. A second. Right.
Okay, share screen.
Karina was also struggling sharing her screen. The beginning was a bit weird. Okay, that works for you.
Yeah. Okay. So let me close this and this. So I have my Lars contract ID right here. And here in the trans TX2, I have Marlowe runtime CLI deposits with Lars's contract ID, my own address. I just saved it with the lender address, but this is the one that I sent to Lars. The Loveless, I want to send 100, so I think that's right.
3 more zeros.
Yes, you're right.
I just want to point out that even though it's also called lender address, that's not the same address that I am using, is it? No, of course not.
No,
I mean,
I generated my own.
I mean, it's just because Robertino also went through this Jupyter notebook, the same Jupyter notebook, so the addresses, the parties are called the same. But of course, it's a different address because the secret keys that are generated are unique each time. I mean, if you go through the same notebook, your address will also be called lender address, but it's a different address. So just right. So that looks right.
Manual side. I don't think I have the transaction.
Well, it's fine. I think that's fine.
Right? Yeah.
That's fine.
Okay, so that will theoretically generate the transaction.
So probably you can't. Can you do a Marlowe runtime CLI deposit help? Probably you have to specify. Oh, but it does say role name address, so it should be fine. No, I was wondering how you, but it says role name address.
Maybe I don't. Okay.
And is lender address defined in your bash right now?
This lender address, yes. Yeah. I
what
just.
Was the?
If I go to the very top where I defined it.
Yes, that's
the one that is sent.
So what was the error message?
The serialized unknown encoding for constructor. Let me see. Unconsumed input. Let's see. Marlowe deposit.
A bit strange.
From party to party. The manual signed. this, I think I don't have this tx2 unsigned file path. So that's
No, I think this one creates, I mean, this one should create it file.
right. Okay, so not sure what this means. Oh, maybe no, that shouldn't. If the target value of the Marlowe contract, one will receive an error message. For example, let's say we deposit incorrect amount or deposit to the wrong party's internal account.
But then the error would be different. I mean, that you could also try instead of if you forget the 3 zeros, for example, that you earlier forgot, but
Right, yes. We have some guides here to debug, but we already have, I mean, we know the contract works, right? So
yes. So that's a bit strange. Initialize. Is this unconsumed input very long?
it's quite long.
Huh.
Not sure what. Let's see.
Do you also?
The contract ID is fine.
Oh, yeah. Contract ID is fine. Check on my side. Yeah. Contract. Yes, the contract ID is fine. You see whether I had something from party to party.
Maybe the Loveless.
I mean, I had the Loveless in double quotes, but I'm not sure that's important, but you could try that.
No, it didn't work.
Did you try it?
Yeah, just did.
No, but I mean, in double quotes?
Oh yeah, it was in double quotes at the from the start. Yeah.
Okay, so it's not that. The joys of Bash.
Okay, so maybe if I change this from party to party to just an address, because it says that it can be used as inputs to the transaction. Not sure.
Yeah.
Yeah. That makes me.
Don't think so, but if you remove the from party and to party, I mean, then it will complain, of course, but let's just see whether you will get the same error.
The deposit funds. Loveless account.
But I think you forgot a backslash somewhere. Yeah, after address. Can you just remove the address again? Or I think that
remove
and that line where you are now.
Okay.
Just want to see whether now you get an error message that somehow from party is required or something.
Yeah. Missing to party and from party.
You just add one of the two now.
Let's see, because I already have this. Okay, let's put just from party. Two-party. Yeah.
Well,
But maybe, okay, yeah. If I do two-party, I get the same error, I'm guessing. Oh, where is it?
you should
Yep.
get
And I
and if you just hardcode your address there, I mean, not use the variable.
sure. Yes, I can do that as well. Where is it? Here.
Mhm.
I will try with the address and then,
Mhm. Okay.
same error. I can also use not sure. Do you if you try to start it, do you have the same error or
Oh yeah, I could try it, of course. Let's see. Let me try that. A second. Just get your address again. Okay. Where was I there? Okay. Let's see what happens if I do it. For me, it works.
this release? I'm just Googling inside the Marlowe docs and says that maybe the serialization errors in Marlowe indicate inconsistency between versions.
So are you also running the same Docker image?
No. That's the issue. Okay.
Okay. I mean, I can give you the transaction in the chat box.
Yep. Yeah, you're right.
So
at least we know there is like a mismatch between versions. Okay. So it's not. Yeah. See, I think if you send me the transaction, I could just compare.
see how I can do that. Because
You
that's
my address, right?
yeah, I mean, I have the transaction ID, but how do I get the actual transaction? Oh yeah, that's this TX. Hang on.
To unsigned,
TX2 unsigned.
which should be in the same
Okay,
folder.
I have it now. Yeah, fine. Just a second. I just sent it in the chat. Many windows. So many windows. Okay, there's that. Where's the chat? So I ran exactly the same command that Robertino was trying to set. Oh, your message is too long. Please try sending multiple shorter messages. Great.
It's
So
from
Slack or I can't send it in the Zoom chat.
yeah, it's okay. Can you see if I switch if I switch the
Yes.
desktop? Yeah.
Yes.
1 second, because I'm not sure. I don't want to dox me or something.
Sure. Sure.
I didn't get the transaction yet.
Yeah, I have to log into Slack first. Sorry.
Okay, so this error we are having, you should basically never have it in production because you create and submit transactions always with the same infrastructure. So unless you update the infra, you shouldn't like run into this problem at all.
I sent it into the Karina's and the three of us chat.
Perfect. I got it. So let's see.
Yes, so I executed exactly the same that Robertino wanted to execute, but for me it just worked. So the reason is, I mean, if you do it, it would work if you use this Docker file or if you use data run. So the problem is just that there were some incompatible versions on Robertino's side. Yeah, looks good. And of course I can create it, but I can't sign it, obviously, because he has to submit it. I mean, he has to sign it and I don't have his private key. I mean, it would be horrible if I could do this on his behalf because then I could steal his money, basically. So that's why I could send him the transaction, but I myself can't sign and transmit it.
Okay. So submit. Okay, there you go.
Yes,
so I'm going
that
to
one.
Yeah, Marlowe CLI. I'm going to provide the unsigned transaction, but like the same submit will sign it and then like submit it to the blockchain.
Mhm.
If
So
you're using the Cardano CLI, you have like two separate steps, one for signing and another for submitting.
mhm.
Okay, so
Yes, this command does that. Okay, that looks good. Look promising. Or not. It looks as if something's wrong with that. Really looks as if your Node version is too old, actually.
oh my God, what's going on?
I got the error recently when when I hadn't updated my node.
Right.
Yeah, I think.
Okay, you Karina, are using the same exact Docker updated.
Yes, actually, I'm using the Meta version to
Right.
show both. Yeah.
Yeah, but you because that was my intention to use Demeter so I can just showcase.
Exactly.
But yeah, it looks like Demeter has different node and Marlowe versions. I mean, Marlowe should be the same because I use the same one as us, but I'm not sure why it's different. But the node version, it makes sense that maybe they are not up to date or something.
Right. So you can't quickly switch to Docker, Robertino?
No, I don't think so.
Okay, then I suppose you have to give me your private key.
Yes, and I can send it to you. Blender.
Blender SC, I think that one.
It might be also too big, so I'm going to.
Yeah, you can stop sharing and if you want, and then I can share again.
Okay, just did.
Okay, let's see. Okay. Okay, let me share again. Sorry about that, but I mean, that's live when you do a live demo.
Yeah, when you try to show
So,
everything. Yeah, and also, I mean, just like to let you know, it's okay if you don't have the latest version of everything, because it's still, I mean, you don't need to keep up with all the updates. It's better if you do, but if your all infrastructure runs in like in some version and there's like a minor update, you can take your time to update it. It won't be the end of the world. You can still interact with the blockchain. Right now we're having issues because we have different versions of everything, which like it shouldn't happen. If you have your own infrastructure, you have just a single version of everything.
right, so let me try. So this I have, but now the required signer. So this is now. So hopefully this works.
Invalid.
Why?
In the file, maybe it's not. It says invalid argument, file name too long.
Ah, it must be the file name. It must not be the key itself. It seems takes the file name.
Oh,
Now,
it's kind of the same error I just got.
insufficient collateral. Don't you have, what do you have at your address?
Oh, maybe that was the issue.
No, I don't think that was the, I mean, I don't think. Oh, but that is weird. That should have been before. I mean, how could it even create the transaction?
You created the transaction. Oh, right, but you used my key, so yeah.
How many what do you have at your address?
1,000, just a single UTXO with a 1,000 ADA.
That should be fine. Ugh. Did I make a mistake here? No, but that is all correct, I think.
Although, wait, I just queried again, and now I have 900. So maybe it went through, and it was like some other issue, like
But oh,
the actual
if
transaction went through.
maybe it's all a bit strange, but okay, we can check that. Of course, we have this. Yes, for whatever reason, whatever that was now. Never mind, it worked. So now if we see here in the Marlowe scan, we see I mean, earlier, let's go like step by step. So details, active, blah, blah, blah. And now in transactions, we see that earlier there was none, now there is one. So this is now the one that Robertino submitted, or rather that I submitted on his behalf. And of course, you must never do that in real life, give somebody your private key. This was not just a demo. Right, and now here we see actually that now the contract has reduced. Remember in the beginning, there were two possible external triggers. Either Karina or Robertino could make their deposits. Now Robertino made his, so now the contract has reduced, as we also saw in the simulator. So I mean, I can go back to the simulator. So now basically we are at this step where now Robertino made his. So this was the original contract where there were two possible actions. Robertino could deposit or Karina could deposit. But now Robertino did deposit, and now the contract has reduced to this highlighted part here. And this is also what we now see on the blockchain in this Marlowe, whatever I did now. Sorry. Now see here in the Cardano's in the Marlowe scan. So it has now reduced. So now the only possible action, except for timeout, is that Karina makes a deposit. Karina, can you do this? Now you have the Docker running, right?
Yes, but I have the same that Robertino is running.
She's using Demeter as well.
Yeah.
Okay.
Yeah, let me try to do, but will be the same. I think I will got the same error as Robertino. Okay. Let me try. So
I did say get the Docker up and running. Nobody listens to me.
yes, but I on the Docker so the method to make two option. No. No.
Mm-hmm. That's
Maybe it's a good
why
time to take another break because it's
yes,
almost
maybe. Right. Just wanted to say that, I mean, I call me old school, but I like to do everything locally where I have full control. I mean, Demeter and these things is very nice, of course, if you don't need to install anything and you can just work in the browser, but then you are completely at somebody else's mercy. And if those people don't have the tools at the correct versions, then you're stuck. So there is something to be said for having a local setup. Of course, I mean, it's a trade-off. Then you also have to, then you are responsible for keeping everything up to date. Anyway, right. So yes, we can have another break, maybe until 5:05 or something. And then hopefully somehow we can do Karina's deposit, and then I must make my choice. And then hopefully, like in time, we will be able to do this. In the worst case, Karina, if you can't get it working, then you must just send me your NFT, and then we can demonstrate that whoever has the NFT has the right to do these things.
okay. Yes.
Okay, but let's have a break, or let's say, I don't know, yeah, 5 past maybe. 5:05?
Okay.
Okay. There's one more thing I wanted to show you. I mean, this was the transaction that we know that Robertino should have transmitted. So if we click on that, we are on Cardano scan and can look at the transaction. And I think that's also interesting. Here, one of the inputs is the 1,000 ADA that Robertino started with from his wallet, and he gets 900 change. So he pays 100 into the contract. This input is the old UTXO representing our Marlowe contract. And as I said, in order to do like a state change on Cardano in a smart contract, you consume the output representing the old state and create a new output at the same address. So here, this is this address that ends with QV. That's the smart contract address representing this Marlowe contract. So that was consumed by this transaction. And then at the same address, there is a new output. And now the datum, if we looked at it, would have changed, representing the fact that now we have progressed in the contract. So yes, and we see that now the value at that UTXO, that contract UTXO, it used to be just these 2 ADA minimum that I put in there when I started the contract. And now after Robertino made his deposit, there are 102 ADA in the contract. So yeah, just wanted to show that. And now the next step would be that Karina does her. But what did I use for the timeouts?
50, I think. Wasn't it?
30. So we still have 20 minutes
Okay.
for this.
Okay.
Okay, so Karina, yours also doesn't work, right?
Yeah, I have some problems. Let me try something. Just 5 minutes.
Oh.
Maybe just because we have a bit of time, or Karina can share his key with you as well. But
No, Karina's key doesn't help. I mean, she could.
all right,
That's true.
Yeah, you're right.
No, it could. I mean, she could share the key, but she could. I mean, this is like highly irregular. Of course, you would never do that. But what she could do, like regular, is send me her NFT, and then I can assume her role, basically. So maybe we should do that. So the point is when you use a role token to define a role, I mean, we hard-coded Robertino's address, but we used role tokens for her and me, which means whoever owns that NFT can assume that role. So if Karina sends me the NFT, then I could play her role, basically, which is a bit unfair, obviously, because I'm the one that decides who gets the money. But maybe for demonstration purposes. So I mean, I have another address. I had these 3 addresses: borrower, lender, and so maybe I can give you the borrower address, and then you can send the NFT there.
Okay.
Just hang on. So we were here. Oh yeah, I can also do this Marlowe runtime log first. So as we saw before, that shows, so this is the creation of the contract that we saw before. And now there is this transaction, Robertino's deposit. And here we also see that now the contract is reduced to the part where now Karina needs to make her deposit. So let me just cut borrower. True. I think that's not defined. Sorry, that's anyway stupid. Echo. I think that's not defined. For some reason, my thing also hangs now. Nothing's happening. Ugh.
I think
I don't know when.
you could remove that and rerun it, and maybe it will stop the process because.
Yeah. Echo. I think that's defined, but let's see. So I don't know why nothing is happening. So some of my notebook is hanging, it seems. Right.
Maybe try run another cell. Just
Sorry, another
maybe
what?
another cell, just to see if.
Right. I can this one again.
Yeah, same.
Not our day, it seems. I mean, I could reload this, but then everything is changed, right? The values are not the same anymore.
No, you have to rerun. Yeah. I mean, if you stopped it already, you have to like rerun the cells again. So maybe you could just use your own keys and do these transactions one after.
Yes. Right. Anyway,
You may have to git reset to get the things you deleted back.
Yeah, let me see whether this now. Somehow now nothing works anymore. Mem- I mean, this also now doesn't do anything anymore.
If you check the Docker compose PS to get the process to see if they are running.
Like this?
Yeah. Okay, they are running, seems.
Up, 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 up. Everything seems to be up. Notebook.
Yeah.
Okay.
Okay.
But this also hangs.
You could try. I mean, if we're going to start all over, we can just stop and then start again.
Mhm.
If you stop it, we shouldn't lose the data.
Yeah.
This might be a great moment to point out that the Marlowe team is working in something like the Marlowe playground, but for actually running and submitting contracts to the blockchain. So it's like a really nice to use UI that will be available really soon. And it's already like almost there, but I don't have but we have to wait maybe just one more month or something like that to have it available for the public.
Right. And also somehow this is misleading now. I mean, normally these command line tools work really well. I love Cardano CLI, for example. I mean, it's normally super reliable and always works. It's a bit, of course, a bit tedious to work with Bash, but it normally works very well. So I think the reason here is not that anything is wrong with Marlowe, it's more this whole Docker thing.
Yeah, I mean, Nix usually works better, but no one wants to install Nix. Yeah. Yeah, but it should, if you have an Intel or an AMD architecture in your chip, everything in Cardano should work fine for you with Docker and Nix. If you have an M2, M1 chip, ARM, you will suffer the consequences, but you can make it work as well.
This doesn't work. With this thing, I don't know.
Did you refresh the
Yes,
page?
I did. I don't know. I mean, it worked so well. I don't know what changed now in the break.
Oh, let me see. There's a command to inspect what the notebook is doing. Let me fetch it up. Okay, so if you run Docker logs and then the name of the service that for you is going to be examples Docker space logs space examples Marlowe notebook. Maybe it will notebook 1. Yeah. And that should give you the log error response.
But I do have that. I mean, here it says I have examples Marlowe.
No, but DS.
Oh, yeah, sorry. Examples.
Serving notebook. Jupyter notebook is running. Okay.
No idea what 404 errors are.
No.
Looks okay.
If you go back to the first thing that you see when you open the notebook before opening the actual notebook, like the folder, and reopen it.
Okay.
When you so like localhost 8080, yes.
Yes.
Okay. Yeah, it's working. So I'm not sure.
Now
Okay.
it works again.
Nice.
Anyway, okay, right. So let's see whether we can somehow salvage this situation. So first of all, I wanted my address. So let's say whatever. Let's borrow. Right. So Karina, you had your 5 minutes. Did you get it to work?
More than 5 minutes.
Yeah.
No yet.
Okay, can you send your NFT to this address, please?
Okay.
While Karina is doing that, let me just check here where we did the deposit. I can modify that already. So this is now transaction 3. The contract ID, I probably should just here. Contract ID. Right. So now, in the case of role tokens, you don't give the address, you give the name of the token. So in Karina's case, that was Karina, and paying to her own internal contract. It's Karina. This change address doesn't matter, but I can use this borrower address now, the other one.
I think I really sent the FT cards.
You did send it?
Yes, I
see.
sent.
So this is this address. And let's see, token list. Yes, I have the Karina NFT in my wallet. Okay. So TX3. Let's see. Okay. Now I created the transaction. Now I must actually submit it. So let's grab this. Go back here. Paste, paste that in there. So the file is now called TX3. The key is now this borrower. That's the one now that where the Karina NFT now sits. So for the test, we still have 5 minutes left until the deadline is reached. Okay. Now I can hopefully check here if we look at transactions. Right, now there's the second one. The one I submitted just now in Karina's name. And now the contract has reduced further. So now it's time for the choice. So I must make my choice. Okay. And we can also check on the, like here, the borrower should now have 800. So I think it started with 900. And so now 100 are gone. We look in the transaction list here in the wallet. So this last one is the one I just did in Karina's name. So I sent 100 to the contract. So now the next step, if you recall, is I have to make the choice who wins. And that's something new now. Oh, sorry, many open windows. I mean, until now we did these deposits, but there's of course also a way to do a choice. I think I have that somewhere already, obviously, because I tried it earlier. Deposit. Okay, but not here. But no problem. Sorry, I'm just getting confused. Where were we now? TX3, okay, here. So now, and as I said, the help system is very nice. Although, okay, so we see what all we can do. I mean, we did the create to create the contract. We did a deposit to make the deposits. Now we want to make a choice. So that's the choose command. And we see, I mean, in principle, I can just, let me just copy this thing, the deposit. So it's choose now. Contract is from party to party was only relevant for deposit, so that's no longer relevant. And so this is now me. So I'm not sure. Okay. Let me just do the same for, sorry. For lender. Lender. Ugh. So I had all of that before, but I had to restart my notebook. Okay, fine. Lender. So now where were we? Choose. So the change address is now this lender address. Lender. It's now the fourth transaction. So the unsigned one we call TX4. And now, of course, I must do some choicey thing. So what do we have? Choice name and then party and the value of the choice. So the choice name was winner. So choice winner. The party is me, and I'm identified by my role token, Lars. And the value, so now I can decide whether Robertino or Carina gets it. And I think Robertino was the first one, right? If we look back in the contract, sorry, contract. Yeah, Robertino was the first. Okay. So I pick Robertino, and I'll explain later because that's a bit simpler to pick him because he has an address. So hopefully that will work. Yeah, looking good. So now I must submit it. Or actually, we still have 20 minutes. I'm not sure. And afterwards, we probably, yeah, let's do it like this. Doesn't matter. Four. And I have to sign it. I hope that's the same problem as before, that it actually did work. And I just get this weird error for some reason. But it says missing witness. Yes. I mean, if we're lucky, it just worked. Of course, we're not lucky. Make a mistake with the names. No, it's 4. That's right.
And aren't you the Lars Eski?
Yeah, but that was just lender, I think. Oh, no.
Yeah.
No, I think that's correct because the lender should have the last. So lender is the one that has the NFT. So that is fine. Let's see whether maybe it was just not there yet. No, unfortunately not. And the timeout is also not reached yet because we said 50, right? 5:50. So there should still be 20 minutes or 18. So that's all good. What else can go wrong? Just try it again. Okay, this says it's error. Validation error. Missing key witness. That sounds as if somebody that needs to sign hasn't signed.
603, the key hash.
Yeah,
But that's not the public key hash, right? So it's different.
I mean, we could figure that out. Maybe I'm just.
You're also using TX4 again, but not sure if that's doing something.
Earlier was TX3, right? That's right. It's the
Yes.
fourth one. Ah, this is it. I made a mistake here. When I defined it. So I called it lender key, but I used the borrower key. So that explains it. So I set this variable wrong. And it works. So I tried to sign with the wrong key, with the borrower key, but the NFT sits with the lender. So obviously that couldn't work. All good, I think. Yeah. And now, if we look here. There are 3, so that worked. And if we now check here, then we see contract closed. So now it's done. And if we look at the actual transaction, this sometimes takes a while until it actually is displayed in the explorers. So let's just need a couple of seconds of patience. I'm confident it will show up. And that would then be the first complete walkthrough through a Marlowe contract. Irritating. But we know it, I mean, it's already displayed in the Marlowe scan, so it should be on the blockchain. But I mean, different explorers sometimes wait longer until they actually show a transaction. Ah, there it is. Okay, right. And now let's see. So as input, so this was the contract, and we see there's now no contract output anymore. I mean, and that is because the contract is now closed. So now there is no UTXO any longer on the blockchain representing this contract. And so this is just to pay for the transaction fees, those 2 inputs and change output. Now this output, the 200, this is now to Robertino because I picked him as the winner. So now the contract paid the 200 ADA that were contained in it to Robertino. And the reason I picked him, because I said it's easier, because Robertino was identified by his address, hard-coded. So in that case, when the contract makes a payment, it immediately pays to that address. So Robertino now has it in his wallet already, the 200. If I had Karina, then because the contract has no way of knowing who has the Karina token at the moment. I mean, I have it right now, but earlier Karina has it. So the contract doesn't know where to send the money. So in that case, the contract will send it to another smart contract. It's also set up by the Marlowe team. And then whoever has the token must get the money from there. So there is another, there's another, so this was that. If we do Marlowe, what I did now. We do Marlowe runtime CLI help again. There's this withdraw command. And so if I had picked Karina as a winner, she wouldn't immediately have it in her wallet, because whoever has the Karina NFT is entitled to that money. So then whoever has that NFT can use this withdraw command and can then specify contract ID and role name. So that would be Karina in this case. And then would basically you have to explicitly then collect your money from this withdraw smart contract. And so then it's a little bit more complicated to actually get to the money. So now Robertino got it immediately. Yes, I'm sorry, this was a bit rough now, but at least, I mean, you have seen it, like everything happened on a public blockchain. It was a testnet, but nevertheless a public blockchain. And yes, everything, I mean, in the end, and I mean, in the end, I was the one that did everything, but I mean, that was just these technical difficulties with the compatible versions. So in principle, I mean, the three of us could have like remotely participated in this contract. And are there any questions at this point?
Not so far.
Yes, and as I said before, I mean, this all looks painful, lots of bash and so on. But obviously, if you use that in a D app or in some application, then one would do all these things under the hood, and the users would have a pleasant UI. But this is basically the low-level way how you can manually step through the contract. So basically everything we did in the simulator with the click of a button, we now did for real on a real blockchain with real transactions. Basically every time we click the button in the simulator corresponds to a transaction on the blockchain. And the smart contract makes sure that only valid transitions can happen. So, I mean, we didn't demonstrate that, but if, for example, the wrong person tries to make a deposit, or if the deposit is the wrong amount or goes to the wrong account or whatever, if anything is wrong, if you try to do a step that's not expected by the contract at that point, then the transaction just fails. So the contract guarantees, the smart contract guarantees that only the correct actions can happen at the correct time, and thus enforcing that basically that the contract is followed. And what else? I mean, with these role tokens, that's actually very cool. So we saw here when I created the contract, they were automatically minted. So these NFTs were created and handed out to the correct parties. There's also a way to use existing NFTs, so that the contract, I mean, when you create the Marlowe contract, the NFTs are not minted; they already exist. So you can also specify existing NFTs, and that's a great way to integrate with other systems. I said earlier, on Monday, and I explained about, I mean, the advantages of Marlowe, that it's simple and can be analyzed, statically analyzed, and so on. I also said that of course for real world things, sometimes, I mean, you need more than what Marlowe can do. So it's similar to in Haskell, how you try to push IO to the periphery. You can like integrate Plutus and Marlowe, do some Turing complete stuff in Plutus, and then do the heart of the business logic, the financially critical stuff in Marlowe. And one way basically to get this interface is with this mechanism, with the role NFTs. So some Plutus mechanism could be responsible for somehow figuring out who gets some NFT, and then basically you can use that NFT as a role token in the Marlowe contract to identify the parties. Right, now we have very little time. Actually, I minted an NFT just for this lecture. I thought we could do another example, like a simple swap NFT against ADA, but probably the time is too short, and the two of you can't do anything anyway. So not sure. I mean, otherwise I could do that example, but I think in 20 minutes I can't do that.
Did you already went through the architecture of all these services?
No, of course not.
Because Marlowe has this really good documentation.
Yes, so I can go back to this Marlowe starter kit. Starter kit.
Also in the marlowe.iohk.io, there's the documentation that is more readable in general.
I think it's in the Jupyter notebooks, right? There's other nice diagrams.
Yes.
So
I send you some diagrams, but it's in the Slack channel, Lars. So there are
okay.
questions for Jason.
Okay.
Okay. Yeah. The question
Right.
is, so are there two smart contracts always in play?
Sorry, let me read it. No, in the case of no, I mean in our case there were 3 smart contracts in play, 2 for the NFTs and for the Carina and the last token, because those, I mean, these native tokens also work with smart contracts, and the Marlowe contract itself. But if you don't use role tokens, I mean, we hard-coded Robertino. If we hard-coded every party, then it would only be 1 smart contract, only the Marlowe contract, basically. But of course, I mean, you can have arbitrarily many. I mean, like complex applications have more smart contracts. But you can already do quite a lot with just 1. So when we look at Plutus next week, most of our examples will only use 1, I think.
Can you hear me?
Okay. Right. Thank you, Karina. So there's that. And also in these lessons, so that we will share with you, or that's just in the starter kit. So there are these other notebooks. And if you, for example, start the first lesson, I think it starts with, no, it doesn't. Somewhere I've seen that. Maybe it was.
It's in the documentation when you set up everything, but also if you go to the chat here in Zoom, the Zoom chat, I sent you the link. Not for
okay. Here, I think.
Let's see.
No, not there. Yeah.
Um,
Okay, let me check in the Zoom chat. Yes, okay. I can't make it bigger than this. Right. So, I mean, a lot of these things maybe at the moment don't make much sense.
you have also in the repository there's a folder with images, and it's one called runtime architecture. If you want to make it bigger.
Right. Images.
Runtime architecture.
Right. That big. Right. So it's relatively complex. But what we did now was this Marlowe runtime CLI that we use today. But in the lectures, they also have examples for, I mean, using the Marlowe CLI, which I'm not even sure where it is in this picture. And then basically you can do the same thing that we did today also with a web server. So, and that's also one of these Docker images that are running now if you use the Docker approach. I mean, I had this here. One of the things that started is this web server. I think that's it. So that basically the things we did now with the runtime, there you can also do that with the REST API. So then instead of Marlowe runtime CLI blah blah blah, you do curl or whatever you use. I mean, so the point is you can do these things from a web application, basically serverless. I mean, you need the Marlowe server, but then your website can basically directly interact with Marlowe contracts. So you don't need to have this command line tool necessarily. You can do it in web setting as well. And then as Robertino said, so there's something called, what is it called? Marlowe runtime or Marlowe run? Marlowe run, I think.
Runner, yeah.
Runner, where, right, I mean, there where you basically have like a nice graphical user interface to do these things. And that's then also relatively smart where I mean, it's basically like the simulator, but for real then, as Robertino also said. So instead of just simulating it, you do real I mean, but it's similar graphical interface where you see, I mean, you can have several Marlowe contracts running and you can start new ones and define parties and so on. And then you always see, I mean, if you can perform an action, like make a deposit or make a choice, then basically there's a button popping up and tells you, okay, now you can do this. Or you can make a choice. And then if you do, then, I mean, you connect it to your wallet and then basically everything is done automatically for you under the hood. Yes.
Yes, all these services already come like pre-integrated with each other, so you don't have to deal with that. And also, besides the runner, the Marlowe team, it has this TypeScript SDK, so you can just integrate your front end with JavaScript, TypeScript, with using just npm install the SDK, and there you have access to all these connections. Of course, you have to run the services in the backend, but at least there is like a really easy to use TypeScript library for your front end.
But in principle, I mean, this is now very clunky to do with this Marlowe runtime CLI we did today. But I mean, in principle, it's always like that, of course. I mean, the substance is the same. I mean, you have to specify whatever, I mean, whether we want to make a deposit or a choice but yeah, everything is of course smoother and easier if you use one of these other things. Yes, but nevertheless, so in principle, I mean, even like this, it's already nice. I mean, you can use Blockly or Haskell or whatever to design your contract. You can try it out in the simulator. And then when you are happy that it behaves how it should behave, then you can like do these things and deploy it and have it actually run on the blockchain. And of course, for real application, you wouldn't expect the participants to work with a command line tool. This is just to basically try it out. But then you have these options like the TypeScript, or there's also a Haskell library, right? Manu client.
Yes.
So I suppose, so instead of doing it with Bash manually, of course, you can also write a Haskell program that does these things. Which, yeah, one could also do. So there, I mean, could spend many more lectures on all these things, but we won't. So instead we will look at Plutus, which hopefully also will make things clearer, because that's basically now was a black box how this actually works with the smart contract. So on Monday, we'll start with actual Pluto's smart contracts. And start with very simple ones. So Marlowe, I mean, as I said, is basically an interpreter of the Marlowe language written in Pluto's. So that's like as complicated as it gets in Pluto. So we will have very simple examples. But nevertheless, I mean, Marlowe is very nice, I think. And I mean, can only do like certain things, but those things really well and secure. Okay, so I think probably we should stop here. Are there any more questions?
Not yet, or maybe we can wait for 1 minute.
Yes, of course. Maybe while we wait, I just want to say back to some. Not really sure what I should check in, because this is now all a mess.
So for next steps, if you're interested in like actually finishing this, you can go through all the other lectures that
Yes,
are
so that's
progressive. Sorry.
yes, they are actually very nice, the lectures, and they all. I mean, for me, it just worked. So I just had to. I mean, you basically can just execute all the steps, and it just works as expected. Just wanted to like say that this Cardano CLI, I'm a big fan of that. So this is not Marlowe, that's Cardano. And as I said, in principle, everything, more or less everything you can do with this command line tool on Cardano. So for example, I mean, we use this query, so you can query the blockchain, check how much funds are at certain addresses, for example, but you can also build transactions. They explicitly specify the inputs, the outputs, and so on. And there are also tools. For example, you can generate your own private keys. So I think that's key. I always forget what is where. No, it's not there. I think it's address actually, which I always find a bit weird. Right. So in the address command of the Cardano CLI is, for example, key gen, where you can generate a new public-private key pair. You can verification key and signing key is different word for public and private key. So I could just generate fresh keys for me, but I just have to specify the files where the public key and the private key should be written to, and then generate fresh key pair like this. Right. I really like the Cardano CLI. It's a nice tool, and also like conversion, certain things like the hash of a public key and things like that you can all do with the Cardano CLI. And then there's also the Cardano API, which is a Haskell library that does all these things. And the Cardano CLI is basically just a thin wrapper to make all of that available on the command line. So with the Cardano API, it's a Haskell library that you can use to interact with the Cardano blockchain. Although that's actually relatively painful to do that, but there are higher level libraries that make it easier. Okay.
We're going to use the Cardano CLI in Bluetooth. And
Yes, I think so. Yes,
it's
at
the
least
first.
once to see it. It's a sort of similar to, I mean, Marlowe, this Marlowe CLI is quite high level, a relatively high level. Cardano CLI is more low level, so you have to be more explicit about inputs and outputs and so on. But I mean, you can use it to interact with Pluto's, the Cardano CLI. But so we will demonstrate that probably on Monday already.
Mhm.
But then there are also, like Robertino said, there's this TypeScript library for Marlowe, so there are also TypeScript libraries, third party, not written by IAG. Lucid is very nice. It's basically a TypeScript library for stuff that the Cardano CLI does, but in TypeScript. So you can nicely interact with the Cardano blockchain from TypeScript. And there's also a Haskell library, Atlas, that does the same thing in Haskell. And there are others as well. So I think we'll showcase all of that in the next 2 weeks.
Yeah.
And there's and the Haskell is really, I mean, a lot has, I mean, we have, I think, almost exactly 2 years now since Plutus was like on live on Cardano.
Yeah.
And in those 2 years, a lot has happened. So it was much more painful 2 years ago than it is now. So the Haskell that you have learned is more than sufficient to do Plutus these days. Whereas 2 years ago, we would have had to add a couple of more Haskell lessons to make it possible. So it's much simpler now than it used to be.
Actually,
Yeah.
if they understood the first 3 weeks, I think that's more than enough.
Yes, I mean template Haskell is used at one point.
Yeah.
And that was a relatively late lecture, but you don't need to understand how to create template Haskell. It's just how to use it. So basically the compilation to Plutus happens using template Haskell. So as we did make lenses, or was it make lenses? Yeah.
Yeah.
Example for template Haskell. There's basically something compiled to Plutus. And but we'll show that on Monday. Okay. There's still no questions.
No, and we are on time.
Yeah. Okay. Then thank you. Sorry, that was a bit yeah.
Eventful.
Not or lots of luck. But I mean, that's always if you try something live. I mean, it's what happens. But at least, I mean, it worked in the end. And I think on Monday it will be smoother, hopefully. But I mean, it's a live blockchain. I mean, I always found it fascinating and very exciting that you can actually interact with something like that, like live. And that in the Explorer, I mean, all of you could have also checked on, I mean, in your browsers that everything we did was like public. And I mean, it's on the blockchain now, so it's basically there forever. I mean, testnet, of course, is not as permanent as the mainnet. I mean, the testnet can be, I mean, normally it should never be restarted, but of course, in principle, it could be. But yeah, nevertheless, I think it's quite cool that we can do these examples, and then you could, like in your browser, check that everything is public. And of course, the same will be true for Plutus as well. So we can also do that on the testnet, or will do that on the testnet.
Yeah.
And maybe just last remark is that, I mean, if I had in the beginning written network equals mainnet instead of preprod, exactly the same would have worked on mainnet as well. So the mainnet is exactly the same. The only difference would have been this address, Robertino's address. I mean, that's then, it looks differently. It doesn't start with test. But apart from that, everything would have been exactly the same. Okay, then yeah,
Yes.
the time. So now there was something in chat. So
Comment for
somebody did check. Jason did check.
Yeah.
You all have
Nice.
you have to check, always check.
Yeah.
Mm.
Yes, exactly. I mean, it is cool, I think. So yeah, so we were interacting with the real world, making changes in the world, not just like some simulated thing. Okay, then have a nice weekend and talk to you on Monday when we start with Plutus.
Bye,
Yes.
everyone.
Thank you very much. Bye, everyone.
Bye.
Bye
Bye.
bye.